In order to show that a function does not have an inverse function, you just need to show that at one point this function is not one-to-one. We can think graphically, and this would be a square function that's been moved up 4 units. And that tells us that if we go to the left and to the right of the line of symmetry there at x equals 0, then we're going to end up with points that are the same, making this not a one-to-one function. So I could plug in f of negative 1, which will be negative 1 squared plus 4. That gives me 5. And I could do the symmetric x value 1. That'll be 1 squared plus 4, and I also get 5. And so having two y values that are the same for different x values automatically makes this not a one-to-one function. Another way you could solve this is by actually trying to find the inverse. So here, if I did y equals x squared plus 4, then I switch, I have x equals y squared plus 4. That will give me x minus 4 equals y squared. And when I take the square root, I have that plus or minus thing happening. And this time we did not restrict our domain at all. And so I do have to have both the positive and the negative in the square root. Whenever you have a positive and a negative for your equation, that means that you don't have a function and therefore you can't have an inverse function.